So today we are doing search suggestion system. You are given an array of string of products and a string search word. At most 3 product name after this type which have common prefix. 3 minimum ones. Okay, so this smells like a trie mobile. So we got some products and then we get mouse. So all of them, but sorted. Okay, then we type O. Yeah, still the same. Then we got mo, so mo and mo. Okay. So basically, there is 1000 products and their length is this. So we can have at most this many nodes in the trie. Well, the question only is that we go down I mean, it's obvious we want to build a trie out of the products and then we want to find this word. Now, if we keep all words in each vertex, right, then we will put a word into 3000 positions and there will be so we will put a word into at most this many nodes in the trie, which is I think fine. Yeah, I think that should be fine. There is 1000 products, so each node will have up to 2 times 10 to 7. That's quite a lot, that's quite pushing it, but I mean, listing is always slow or takes up a lot of memory. So we have two choices. We can either every time we advance through the pointer, search entire subtree and its leaves, or we just store all the words in the so we build a trie and then the word which correspond to a root to leaf path, we store the word in all ancestors of the leaf or the leaf and the leaf itself. But then we will store, like, let's say an index, and we will store that index in this many nodes, or like this should be fine. There will be at most, I think that will be fine. So let's see. First we need a trie class or node, and what do we need? Def init self, and then we need I don't know. Well, self child is none times 26 or k, like that. So that's self child, and then like by default it's false, and then that's it, I guess. And then we do like def. Let's not do anything right now. By doing the code we will see what interface we need. So what do we do? Well, node is node, right? And then for p in products self insert into node product p So now what do we do? Are the words unique? Yeah, the product words are unique. Okay. So let's try to define the insert operation, which will have a node and then the prod, but that's also a function. So let's call it p and then index, right? So if index len p return maybe, so if not node decodes p index decode character return, it's like int c minus int a. I think it should work like that. In C I could just do type conversion, but whatever. So if not known decode so this is child. If not node child, then node child equals node and then let's see, node child node leaf is true, so we are at the end of the try, and then we need self products, like a list, node products append, we should put some prod index, so we append indices instead of the entire words. For that we need the index, so enumerate index and then we insert node p index plus 1 prod index. Okay, that's fair. And after we insert everything, so index 0 while index is less than, we do this. So child decode search word index. If not, node child then ans append empty list since there is no match, and we create a fake node which will have no children, so there will not be match. There will be no match in the when comparing until the end of the word. So node child equals node do we actually, why am I setting this leave node? I actually don't need that. Okay, and then so we got a child, and then we wanna node child, and then ans append node products, and then return ans. That should work, I guess. Insert doesn't work great. What the hell? Type int has no len. What do you mean, bruh? What the freak? That is weird, bruh. Yeah, I swapped. Okay. I think self-decode. Self-decode, and then self-insert and self-decode. I'm really... That is weird. It's like ORD. Wait. Yeah, okay, that's it. So ORD C minus what? List object has node if not node child, that has to be so confusing. Should work. Self decode. Damn, I really cannot type. Node child. That's a horrible naming, but who cares? So node pro. What the fuck? Non-type. What the freak? That's weird. Wait a minute. Print node. That is weird. Let's see, let's print node. Let's print node child. So there is only something. A, B, C, D, E, F, G, H, I, J, K, L, M. Seems fair. I, J, K, L, so at 12. Child, like that. Yeah, index is not advancing. Interesting how many bugs you can make in such a small products. I for I in node product, so we want to transform the indices into products. Okay, so prods is this, prods sort, and unsappend prods free. Okay, now let's see if this dies on memory. Okay, it doesn't. That's quite interesting. I mean, it's shit on memory. So, I mean, we could try the different approach of traversing the entire tree, but that. Okay, and then with like node. Maybe like that, so def gets up 3 products. So wish, that's just for safety. And then so this is ans, and now if node product unsappend this, and now for I in range, or yeah, in range k, if node child I so if node child I, then we wanna get sub ans get products self node child I, right, and then ans and sub ans. passing self as an argument. That's weird. Okay. List and string. That's weird. Maybe it's extend. Okay, let's see. So 112 milliseconds, 1100. Okay, so of course it's way slower. Yeah, I can just do this. Question is binary search. What the hell? Okay. Okay, that's interesting. All in prefix and DFS. And DFS to find at most 3 words. What? What? Who made this? We find representative node in len prefix and DFS to find at most 3 words, which is O1 operation. Are you kidding? No, it's not O1 operation, it's NO again operation, dude. Yeah, that's not the best editorial, but whatever. Oh, but sorting before is a good idea. That might help. From 120 milliseconds. What? Okay, a little bit faster. Whatever. This Lee guy is on every problem, bro. That's fair. What's S? S find current break. Python always with crazy solutions. Anyways. Oh, I didn't remove the sort. (101), (91), so it didn't change anything. Okay, whatever. Let's call it try. We can, if we store all products in a trie and in each node we store the products of that subtree, then we start in the root and each prefix moves us in some direction in the trie. All subtree products in each node, we simply pick the free approach. When building the trie, we store the product indices instead of the entire products in order to not exceed the memory limit. We also pre-sort the products before inserting them, which will allow us to simply pick the first 3 products of each simply pick the first 3 products for each prefix. Time complexity, well, first it's n times m I think that's it, because since we first build the trie in O of where n is the number of products and m is the length of the longest product, and then we answer then we get the answer for each prefix in O1, since we have pre-calculated it for each prefix for each node of the trie. What's the length of search word? Okay, so plus W, of which there are W. Space complexity can be quite tough. Let's say it's like well, let's say we have, okay, the words are distinct, so it's not gonna be that bad, but let's say they are equal in all but last 2 characters, which is like 26 times 26, which is like 500, or all but 3 characters, so it's still gonna be deep, the tree. So in each node so there is nm nodes, and in each we got at most n prefixes. I'm not sure about that. At most n products indices in at most O and M trie nodes. It's fair. guess. Fair enough. Okay, goodbye.